Hello pre-calculus students, these are your notes on graphing polynomials. The first part should look really familiar. We talked about end behavior of polynomials in our last unit in Unit 6. So you start by talking about if the lead coefficient is positive or negative. So the lead coefficient, remember, is the number in front of the term with the biggest exponent. And often it's in front of the whole polynomial, but it doesn't have to be. You can have a 2x squared here, and you can have a minus x and a plus 5. So this is the term we're looking at, the one with the biggest degree. And we start by looking to see if the lead coefficient is positive. That tells us that the right side will go up. And if the lead coefficient is negative, like negative 8x to the 3, then that would tell us that the right side would go down. And then after you figure out what's happening on the right side, you go to the left side. So you look to see if the degree is odd or if the degree is even. If the degree is odd, then the ends are not going to match, which means the left side will be opposite of the right side. And again here, if the degree is odd, then the left side is opposite the right side. So same rules as from before. So down here we're going to just make sure we remember end behavior. Find the term with the biggest exponent. Here we go. All right, they happen to all be out front, but don't be fooled, that doesn't always happen. And you look for your lead coefficient. So if there's no number there, that's a 1. That's a 1. And this one has a negative. This is negative 1. So if the lead coefficient's positive, the right side is up. Then look at the degree, it's even, so the ends match. So this side is also up. Then it says to write the end behavior formally, so we would write as x goes to, and you can choose if you want to say left or right first. We've been doing right first a lot, so as x goes to positive infinity, f of x goes to positive infinity. And as x goes to negative infinity, that's this side, the y is still going to positive infinity. F of x still goes to positive infinity. Okay, next one. Negative lead coefficient tells us the right side's down, and odd degree tells us the ends do not match, so this side should be going up. And then we write it formally as x goes to positive infinity, that's the right side, f of x goes to negative infinity. Then the left side, as x goes to negative infinity, y goes to positive infinity. Okay, so I think you have the idea. You should probably stop the video for a moment and just make sure you can do these before going on. I'm going to continue doing them, but you can stop it, try them on your own, and then play it to make sure you got it right. All right, so you should have these answers already. You're just checking your work. We're looking at the negative 1. That tells us that the right side is down. And then the degree is even, so the ends should match. So this would be as x goes to positive infinity, f of x goes to negative infinity. And as x goes to negative infinity, f of x, that's over here, goes to negative infinity. All right, last one. Positive lead coefficient tells us the right side is up, and odd degree tells us the ends do not match. I'll do this one up here. So as x goes to positive infinity, f of x goes to positive infinity. That's over here. For the left side, x goes to negative infinity, and the y is going down, so f of x goes to negative infinity. All right, I think we have end behavior. Let's talk about zeros. Zeros are where the function crosses the x-axis, and sometimes a function can have a single 0, remember root means 0, a double 0, or triple zero. So this would happen if you have a factor that happens just once. This would happen if your factor happened twice. Like if you had x minus 2 and x minus 2 again, that's called a double factor, and it makes a double root. And then the triple root is when the factor happens 3 times. Obviously, factors could happen 4 times, 5 times, 6 times, but this is what we focus on in pre-calculus. So if it has a single root, what happens is that it's going to pass straight through. So the graph is going to pass straight through the 0. So in the first example here, it says single root at -4. Oh, sadly, I don't see a -4. We have to adjust our graph a little bit. That looks better. Okay, so we have a single root at -4, and at -1, and at 3. And it tells us A, that's your lead coefficient. So that means your lead coefficient is less than 0, so your lead coefficient is negative. All right, so if my lead coefficient is negative, that means that it's going down on the right. And it has to go through the 0, so that's where I'm going to start going down on the right. And then I need to connect to my next 0, like this, and then connect to my next 0 like this. So this is just a sketch. Obviously, the graph doesn't look exactly like this, but this is the most important information here with your zeros and your end behavior. All right, here we have a single root and we have a double root. So a double root, it bounces off the x-axis. Instead of going straight through, it comes up to that point on the x-axis and then it bounces back up again. So it bounces off the x-axis. And the triple root is not on this page, but you will see this on the next page. The triple root, it passes through, kind of like a single root, but it passes through with a little wiggle to it. So I'm going to write that down. Passes through x-axis with a wiggle. Okay, so this one has a single root at -4. Again, I'm missing some lines here. And I'm going to need a 3 again. Okay, so it passes through at x equals -4 and x equals 3. And because of the double root, it's going to bounce at -1. Now a is greater than 0. That means my lead coefficient is positive. So on the right side, if my lead coefficient is positive, it's going to be going up. Single root at 3, so I pass through that one. And I come up to this one. Now I have a double root at -1, so instead of passing through -1, I bounce back again, like that. And then this is another single root here at -4, so I go through. So it makes kind of a W shape, like that. Okay, we're finished with page 1, and I made you a new video for page 2, so you can stop this video and start up the next one.